So next is conjugate addition of alpha beta unsaturated carbonyl compound. So the reaction involved is Michel reaction. Okay, conjugate addition. Conjugation of a double bond to a carbonyl group transmit the electrophilic character of the carbonyl carbon to the beta carbon of the double bond. So here is conjugated carbonyl, we call it enol or alpha beta unsaturated carbonyl. Okay, so here as you can see, okay, this one electron move to the O minus, so this one pi bond, okay, electron move to here to become C plus, it become O minus. Okay, so enolate, so it become C plus here, this one is double bond, and here O minus. Conjugate addition, 1,2 addition or 1,4 addition. Nucleophile attack either at carbonyl group, aldehyde, ketone or carboxylic acid derivative, or at the beta position. Nucleophilic attack occurs at the carbonyl group. Protonation occurs at the oxygen atom, we call 1,2 addition. This one, nucleophilic attack at the beta position. Oxygen atom is the fourth atom counting from the nucleophile, so we call as 1,4 addition or conjugate addition. Okay, look at here. This one is alpha beta. Okay, we have a double bond, we have a C double bond O. So nucleophile, okay, the presence of acid. So here you get the 1,2 addition. Okay, get 1,2 addition. Nucleophile attached here. Okay, and this one to become OH, we call as 1,2 addition. But for this route, we form ketoenol as a 1,4 addition. Okay, 1,4 is one nucleophile, okay, attached at C1 and alcohol at C4, so we call as 1,4 addition in ketoenol form. Okay, so 1,2 addition, nucleophile add to the carbon. 1,2 nucleophile add to the carbon, which is one position. Okay, this one carbonyl. Okay, the hydrogen adds to the oxygen, which is in the 2 position. Okay, position 1 nucleophile attack, position 2 we add the hydrogen, so that's why we call as 1,2 addition. This one nucleophile added to the carbon beta to the carbonyl. Okay, so ni this one alpha beta, so nucleophile attached at beta carbon, then hydrogen go to the alpha carbon to the carbonyl, we call it 1,4 addition. So look at here the difference. Okay, nucleophile attached to this nucleophile electrophile. Okay, 1,2 addition. This one is this one nucleophile 1,4 addition. So this one is for 1,2 addition. Okay, step 1, addition of nucleophile to C double bond O. Okay, nucleophile attack carbonyl. Okay, so what happened? This one O minus. Protonation of alkoxide. Protonation alkoxide. So we accept proton to become alcohol here. One we call 1,2 addition at the same carbon. 1,4 addition. Conjugate addition of the nucleophile. Nucleophile attack this electrophilic from beta carbon. Okay, and electron move to the here. Okay, so here electron move to the O minus. Protonation of enolate. Okay, nucleophile attached. So this protonation of enolate abstract this proton to become OH. So position 1, 4. It's become ketoenol tautomerism. Okay, so the difference 1,2 and 1,4, okay, determined by the nature of the nucleophile. Nucleophile is a strong base such as grid reagent. So either 1,2 or 1,4 reaction are irreversible, undergo kinetic control. 1,2 addition, carbonyl group are fast to give the 1,2 product. Nucleophile is a weak base, so alcohol or amine, then 1,2 addition is usually reversible. Competition between 1,2 1,4 addition, so in this case 1,4. Okay, so here the clue is nucleophile strong base, so favored to form 1,2 addition. Nucleophile weak base, so favored to form 1,4 addition. Okay, look at here. This is a 1,2 and 1,4 addition. Nucleophile is from the strong base. So by using the presence by using this solvent, so we get this nucleophile. Okay, attack this carbonyl, and electron move to the O minus, and anion abstract proton to give OH. So favored to form 1,2 addition, simple addition product. Okay, so this one is the keto. This one enol form. This one is keto form. So this one for 1,4 addition. Okay, cyanide is a very weak base. Using alcohol. So what happens? Cyanide with nucleophile attack to the beta carbon. So this one attach. Electron move to here. This one move to jadi O minus. Okay, O minus, and then O minus abstract proton to give the end product 1,4 addition. Okay, another example for the 1,4 addition. Okay, so this one which 1,2 alpha beta unsaturated carbonyl metahydride. We use a metal. Okay, metal. So what happen? You get this one product. If sodium borohydride, also you get the unsaturated carbonyl, C double bond C. Alpha beta unsaturated carbonyl. Okay, so this one for the Grignard region. Okay, this one H. Okay, this one it become OH. Seems to like this one. So Grignard region RMGBr. Okay, so this one become R attached on the carbon and OH. So this one for organolithium RLi. So R will attach on the C atom. Okay, this one unsaturated carbonyl. This one unsaturated carbonyl. Nucleophile which add 1,2 unsaturated carbonyl, different of the nucleophile. Okay, this one for the 1,4 alpha beta unsaturated carbonyl 1,4. So this one nucleophile attack beta carbon and then move here to become the end product of 1,4 unsaturated carbonyl. Okay, look at here the position of the nucleophile attached. Okay, and this one. Okay, for Michel addition, addition of enol anion to the double bond alpha beta unsaturated carbonyl compound. Okay, so this one is Michel acceptor, electrophile with a pair of electron. Okay, Michel donor attack nucleophile which donate a pair of electron. Okay, look at for this one. This one is Michel donor, Michel acceptors. So here is the example of Michel addition. Okay, so here is lone pair. Okay, here is cyclic ketone. Okay, base. Okay, base abstract hydrogen from the attacks for this alpha carbon, so become C minus, and this one enolate anion. So this one enolate anion, okay, nucleophile will attack this beta carbon, okay, so electron move to here and move to here to form 1,4 addition here, okay. So your end product, it become this one. Okay, example here is melanic ester react with the boot 3 into on, okay, alpha beta Michel addition. So here you get the product 1,4 addition. Okay, it depend on the starting material and also the reagent we are use. Okay, this one is hydrolysis and decarboxylation Michel product. So this one is 1,4 product hydrolysis. Okay, hydrolysis is mean we want to remove the OR, okay, to become alcohol here, sorry, to become the carboxylic acid. Remove ester to become carboxylic. Decarboxylation, we want to remove carboxylic to become keto acid. Okay, if you using the decarboxylation reaction involve heat. Okay, hydrolysis means we want to remove ester to form the carboxylic acid, and decarboxylation carboxyl. So we want to remove the carbonyl here to form the keto acid. So effect on the acidity, alpha hydrogen is more acidic because electron withdrawing group is present. Okay, electron withdrawing group make enolate anion more readily like to form. Enolate anion are more likely to form. The reaction will become more reactive and more favorable to occur, like this. Okay, carbon, alpha carbon located between this electron withdrawing C double bond O. So that's why alpha hydrogen is more acidic. Okay, so you can do the exercise. So next is Robinson annulation. Okay, Robinson annulation can be used to build a new 6-membered ring or conjugated cyclohexanon. There are two-step process: combine Michel reaction with the intramolecular aldol condensation with dehydration. Okay, here, okay, alpha beta, and this one is ester, this one is alkene. Okay, Michel reaction, so you get this Michel product. Okay, followed the 1,2 or 1,4 addition. So continue with the Aldol reaction, so you get the annulation product. This is annulation product. Okay, at the same time cyclize. Okay, example of Robinson annulation. As you can see here, this is the alpha carbon. Okay, this one is the vinyl ketone. Okay, alpha beta Michel addition. Okay, so what happened? Base, and this is alcohol. Okay, look at here, this one alpha. Okay, this one react with this one. Okay, this is base, nucleophile abstract this proton from beta carbon, so become enolate anion. So enolate anion C minus will attack this one alpha hydrogen, so that's why you get this one Aldol condensation. Okay, after that continue this process, okay, to form the Aldol condensation, which is eliminate the water, eliminate to form the pi bond here. Okay, this one, this is a part of Michel addition, and this one a part of the Aldol condensation. So the overall mechanism we call as Robinson annulation involve Michel addition, and lastly involve aldol condensation. That is Robinson annulation. So the mechanism for Robinson annulation, this ketone react with this unsaturated ketone. Okay, so this part is Michel addition, this base. Okay, either you using a strong or weak base, so it's the product is depend on your base. If strong base, you get the 1-2 addition. It's weak base, you get 1-4 addition. Okay, that's why we call Michel addition. So here you get the lone pair, this base abstract this proton, to form enolate. So enolate can attack this carbon atom, or can abstract this proton, beta alpha hydrogen. Okay, so it's become this one. Okay, this attached at this one. Okay, so for Michel addition product, and then move to the aldol condensation. Okay, aldol condensation by using a base. Okay, abstract this proton to give the alpha beta unsaturated product. So here is more clear about the mechanism. Okay, this one is base, abstract this proton. Okay, abstract this proton to form the enolate. Okay, this one enolate anion, and then this enolate electrophile in nucleophile abstract this proton, so that's why attach here. Okay, sorry, the previous I said this one enolate anion, but this is enolate anion for the ketone, not for the alpha beta unsaturated ketone. Okay, so this one. Okay, because why? How to select? Because this is alpha hydrogen with the alkyl group, but this one the alpha carbon is less hindered compared to this one, so that's why less hindered is become enolate anion. Okay, after enolate anion, so attack this beta carbon to form the product here. Okay, so next step. Okay, electron, this one will move here, so this one become C minus. So C minus, okay, abstract this proton to get the CH. Okay, the ketone. After that, cyclic aldol. How to cyclic? Okay, so this OH minus abstract this proton. Okay, become a lone pair here. So this lone pair attack to this one to form this 2 cyclic. Okay, so it's become the aldol product, and after aldol, okay, so the one to become here O minus abstract proton to become aldol product. Continue aldol product, dehydration. Okay, this one abstract this proton. Okay, so it's become double bond here, and this one is left to become water. Okay, so please memorize the mechanism of Robinson annulation. I repeat again, step is from Michel addition combined with the aldol reaction, and lastly end product is dehydration. Okay, first step Michel addition, you must have the Michel addition. Next step is cyclic aldol, and lastly is dehydration. Why cyclic aldol? Because of Robinson annulation. Okay, Robinson annulation, you want to build a new 6-membered ring. Okay, That's why you get here the 6-membered ring. Okay, the keywords came from the reaction Robinson annulation. We want to form the cyclic ring. Okay, so the reaction involved are Michel addition and Aldol condensation. As you can look here, okay, 2 step Michel reaction with intramolecular Aldol condensation, we had the hydrogenation. So you have the alpha carbon and you have the alpha beta carbon. Okay, alpha beta carbon, and you have the alpha carbon. This one is alpha carbon, this one is alpha beta. So look at here, here is alpha beta. Okay, here is only alpha hydrogen. So the first step for mechanism, okay, we want to form enolate from the alpha hydrogen. Okay,